In this video, we're going to cover the concept of concavity. Now, if we take a look at a function, say an x squared function, you know that this graph looks something like this. Now, concave up is specifically what this graph looks like. This is what we call concave up. Next, if I look at, say, a graph that looks like this, y equals negative x squared, then this graph is facing down, like this. And this is what we call concave down. So if we have something that looks like it's again opening up to some extent, then we'd call that concave up and concave down. Now, this can be re-evaluated using calculus, but before I do that, I want to go ahead and show you that a cubic function, if I have some additional pieces to it, it's going to look something like this potentially. Now, you'll notice that there's a concave down piece up till about here. And then from here up, that is concave up. So at that location right there, we would call that an inflection point. Now that right there is where the actual second derivative, is equal to 0. Or, one more time, does not exist. That right there is what we call a critical point of the second derivative. So again, we have concave up, we have concave down. In any function, we can have concave up and concave down, and where the concavity changes, you'd identify that being as an inflection point. Now, the only real reason that we're covering this in class this time around is specifically because it helps reinforce the concepts of critical points. It's just doing it for a second derivative. And it supports the concept of identifying, again, derivative, second derivative, and the second derivative, this is going to have a second derivative that is positive, and this is going to have a second derivative that is negative. So knowing that information, it follows the same exact rules as of a decreasing concept, just on the second derivative instead of the first.